Hello students, in today's video let us learn about Young's double slit experiment. First of all, we had studied about the superposition principle and we had looked into the constructive interference phenomenon and the destructive interference in light waves. So there have been many attempts to experimentally observe this interference phenomenon of light. And the most noted one are the one done by Grimaldi in 1665, and in 1801 Thomas Young successfully demonstrated the interference phenomenon. In 1665 Grimaldi tried to produce two sources from the sunlight, and he tried to observe the interference phenomenon due to the light waves coming from these two sources S1 and S2. But since these two sources weren't coherent, the interference phenomenon was not observed. He got a uniform brightness. In interference phenomenon, we should have dark and bright bands. But in 1801, Thomas Young was able to observe the interference phenomenon. So this is the experimental setup that he used. He first produced sunlight. He passed it through a single small pinhole, and from that light he derived two other light sources by putting two more pinholes here on a screen. So the light wave coming through this pinhole will be distributed into the space. From there, these two smaller slits will produce, or smaller pinholes will produce, two other light sources. Since these two sources are produced from the same source, same initial source, these are coherent sources. They will have the same frequency and a constant phase difference. And Thomas Young was able to observe dark and bright bands on a screen. So the light wave, the incident light wave is uniform. It is passed through a screen on which a pinhole is marked. And after that, we have another screen on which we have two pinholes, and through that we will obtain an interference pattern. So first he got a very faint pattern, a colored band, because he used sunlight, faint colored band. But later he modified this experiment by using sodium light of 589.3 nanometer or 5893 angstrom, and from there he passed that light through a slit. So he replaced pinhole by a slit. So there is more light coming through the slit, and this light was again passed through two other slits, and finally he got the interference pattern. So as you can see, he produced these two sources. From there, here we have the source number 1 coming from the slit 1, then the source 2, which is the slit 2. Light waves originating from these two sources are actually forming these kinds of waves, and they superimpose in the space to give constructive and destructive interference. And if we put a screen at the end, we will get the bright and dark regions separated. The bright regions correspond to places where constructive interference is happening. Dark region correspond to places where destructive interference is happening. So bright correspond to constructive interference and dark correspond to destructive interference. So in certain regions, the condition for constructive interference will be satisfied. There we will get bright band, and in certain regions where the condition for destructive interference is satisfied, we will get dark bands. So this is the basic mechanism. From a single light source, two sources are produced, these S1 and S2. This is the initial slit, yes, maybe we can consider like that. And S1 and S2 produce coherent waves. They interfere in space, and if you put a screen here, you will get dark and bright bands on the screen. So this is the basic experimental setup. of Young's double slit experiment. You will have to study to draw this figure. This is the experimental setup arranged by Young. Now, in the next class, we will learn about the positions of these dark and bright bands and the equation for bandwidth. As of now, I hope that this experimental setup is clear for you. Thank you.